This tutorial should be viewed after viewing the floor joist tutorial. The concepts in this one build on those previous. In this tutorial we'll design deck beam A as shown in the solved examples on the Construction Calc website. So we start in the general information here and input deck beam A. Now we will put in the correct span. This deck beam is a cantilevered beam, which means it has an overhang, so actually it has two spans, the cantilever span and the main span. We input the main span first. In our case it's 18.25 feet. And the allowable deflection of the main span will go back to code minimum L over 360 and L over 240. Because there is a cantilever, we're going to select yes here, and when we do that, some more rows unhide. Now we can put in the cantilever length, which is 4.67 feet, and we can set the allowable deflection of the cantilever, but we'll keep with the default values. There is no pitch to this deck beam, and the load duration comes from people, so again it's a live load of with a load duration factor of 1. Loads from continuous member. In this case the answer is yes, because the loads come from the deck joists over this beam and they are continuous, in other words not spliced on top of this beam. So they're continuous over the beam, that means the loads come from continuous members, so that's yes. Now we're going to add the self-weight, because the dead loads that we put in below are not going to include the weight of this beam itself, so we have to add that separately. There are no other loads other than uniform loads because the deck joists are all uniform over top of this beam. Now we look over here to the right and we will probably use a pressure treated member because this beam is exposed to the elements. So we're going to select pressure treated. It will be used primarily in a dry condition, even though it will be getting wet sometime. This factor is if it's wet most of the time, and in our case no. Where this would be put in, that's going to be no, and temperature is still 100 and less. Now we come here to the uniform load section, and the live load is the same for residential deck. The deck load, or the dead load, will be 10, and again that is viewable from this pop-up. And the tributary width is the most difficult part of this, but it's really not that hard. The load comes from the joists, and the width of the tributary area is always measured perpendicular to the member you're designing. The cantilever end of the joists, all of that load comes to this beam, and then half of the span of the joist, of the main span of the joist, goes to this beam. So to restate that, there are cantilevered deck joists over this beam. The entire cantilevered end of those deck joists is supported by this beam, as well as half of the main span of the deck joists. So we are going to input that. Since I don't like calculators and Excel allows in-cell math, we're going to put that right in here, and it's going to be equal 3.25. That is the length of the cantilever end of the deck joist over, plus 10.75 divided by 2. That's half the span, the main span of the deck joist. So 8.63 then is the tributary width of the loaded area acting on this beam. That's it, we're done. Now we click calculate and scroll up and make sure that the load diagram shows what we intend to be designing. And in fact, there's the main span, there's the cantilever, and there's a uniform load on top of the beam, so that looks right. Now let's go down here, and we're going to pick hem fir instead of Doug fir, because hem fir is one of the few species that can be pressure treated, and probably a number 2. Repetitive member, no, because this beam acts all by itself. In 4x and smaller members, nothing works. In 5x and larger, if we pick number 2, we can see that they are huge, and probably nothing in this table we would actually want to use, which is going to force us into a glue lam. So we scroll down and we see that we have glue lams here. We don't want a Doug fir glue lam, so we're going to pick a hem fir over hem fir 24F V2 glue lam, and now we see something that looks a bit more reasonable. This 5x15 looks pretty good, or the 5 1/8 by 13.5 looks pretty good. We could stop right there, select any of these, and be fine. But let's go down and see how efficient they are. So we're going to select sawn wood down here in the final selection area. I'm sorry, we are going to select glue lam. There it is, because the sawn wood was too big. And it just so happens that the 5 1/8 by 13.5 pops up, and it just barely makes it by less than 1%, and deflection is the controlling criteria. We can see that as far as strength goes, it's plenty strong. The bending stress is it's 54% over designed, and in shear it's 110%. It's double the size that it needs to be for shear. So it's deflection that controls the size of this. We could print this out and we would be done. Also, we can see what the reactions are at each of the supports, and at the cantilever support we can see that under full load we've got 7,000 pounds out there. That's going to translate to a big footing below it. We can also see the maximum moments and deflections in this section here.